circles today. Chapter 10, Section 1, circles. So we need to define some key terms here. First, let's define what a circle is. It's the set of all points a given distance or certain distance from a given point. So if you took a point somewhere in space and you designated a certain distance from that, let's say 1 centimeter, and we drew all the points that were 1 centimeter from that original point. It'd be kind of like attaching a 1 centimeter string to a pencil. And that was your radius. And if you connect all of those dots that are 1 centimeter away from that original point, then you get a circle. That first point that we started with is the center. Okay, just as you see up here in our diagram, that's where we started. That's where we started measuring from. So that is the center of our circle. And the distance that we measured from that point, from that center, is the radius. A circle with center P is called circle P, or you can use a circle symbol, but notice that it's a capital letter. And here's our example. So we have point P here in the middle. We label it with a capital P. The given distance that we choose to measure from P out is our radius. And then if we draw every single point possible, that distance from point P, then we get our circle. So have an idea of how to define a circle, how to name a circle, and what the center and the radius of the circle is. So again, it's the set of all points in a plane that are a given distance from a given point in that plane. So it is two-dimensional. It's on a plane, on a flat piece of paper. You can draw a circle. Now there's several things that we can draw within a circle. We already learned the radius, which is from the center to the edge. If we draw a segment from a point on the circle to another point on the circle, it has a name, and it is called a chord. Goes from a point on a circle to another point on the circle. If the chord goes through the center, so that it's at the widest part of the circle, notice here the widest part of the circle, then that chord has a special name. It's still a chord, but it has a special name, and it is called the diameter. Okay, so let's see if we can identify parts of a given circle here. What would you name this circle? Remember, we name it by that middle point, and it should have a capital letter. So you can either say the word circle, write it all out, or you can use your circle symbol here. Either way, it should be E, circle E. So find that middle point. Now let's use the same circle and find the radius. Plural for radius is radii. There's actually 4 different radii in this circle. It says to name a radius, so you only need to name 1, but you should recognize all 4. Okay, and because they are segments, they have endpoints, you could name it DE or ED, but remember they start at the center and go to the edge. It's just halfway across the circle. So we have ED, EC, EB, and EA. 4 different radii. Okay. Hopefully you got those right. Now let's name a chord. Name a chord. I actually see 4 chords. Remember, a chord starts on the circle, not inside, but starts on the circle and goes across and lands on the circle again. So the endpoints are on the circle. So here AD, or you could name it DA. AB is another one. BD goes all the way across through the center, as does AC. So there's 4 different chords there, 2 of them of which are diameters. So then our next question is, same circle, name a diameter. Remember, a diameter is a chord, so it has endpoints on the circle, but it has to go through this center point here. So what 2 chords do you see going through that center point? You see BD and AC. AC and BD. Now some rules about circles. Congruent circles, remember congruent means same size, same shape. So if they're the same size, obviously they have the same shape because they're circles. If they're going to be the same size, then it would make sense that their radius or their diameter or their circumference, all 3 of those things will be the same. So if you have congruent circles, their radius, their diameter, and their circumference will all be congruent. So if I know these 2 circles are congruent, as my symbol shows me, if this diameter is 10, then this diameter has to be 10. So if I have 2 more congruent circles, and I know that this radius is 8, why does it do that? And I know that this radius is 2x. What is x? Well, if my radii are the same, then I would just set them equal to each other. Remember our mantra? When parts are congruent, we do what? We set them equal to each other. And then we just do the algebra. So x equals 4. It's all about understanding the relationship in these figures. And then your equation will follow that relationship. Okay, so we just mentioned in the previous slide radius, diameter, and circumference. What is the circumference of a circle? You should have learned this in junior high, maybe even before then. Let me erase my slide. The circumference is the distance around a circle. It's like perimeter. We just give it a special name. It's the same thing as perimeter of a circle. So the distance all the way around, and there are a couple of formulas we can use. They mean the same thing. Circumference is going to be twice the radius times pi. Well, twice the radius is diameter. Now remember, pi is a number. Even though we have a symbol for it, it represents a real number. 3.14 blah, 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 blah. Okay, it goes on forever. So we're not ever going to replace that pi with something else. We're not solving for pi. Okay, even though it's a symbol, we're going to use 3.14 every time. We're not solving for that. Where did pi come from? Anybody ever asked that question? What exactly is pi? And why is it so important? If you take the circumference of a circle and you divide it by its diameter, you will get 3.14 and so on every time. Now, it's kind of hard to do this as an activity because your circles have to be perfect, your diameter has to be exactly in the middle, and your measurements have to be extremely accurate. but we're going to try it, see what we come up with. But just know that for any circle, this ratio will be 3.14. And that's where pi came from. So the definition of pi really is the circumference divided by the diameter. Okay, so let's use this formulas, to find some missing values here. We have circle R, it has two diameters, ST and QM. If ST is 18, what is RS going to be? So if this whole distance is 18, what is half the distance going to be? Well, we know that radius is half the diameter, so we just plug in our values. Okay, you probably could do that in your head, but I want to show you the algebra. Half of 18 is 9. So again, think about the relationships. Don't just jump into these problems and write down the first thing that pops into your head. Think about what you're saying and what the relationships are. It's the relationships you need to learn. You've got to memorize if you don't already know them. Okay, Rn. So let's find, what is Rn? Well, it goes from the center to the edge. So that would be a radius. What is Rp? Well, it also goes from the center to the edge, so it's going to be a radius. They're going to equal each other because all radii are congruent in the same circle. It's the same distance. Remember, that's the definition of the circle. And so it has to be 2 as well. Okay, this one looks like it could be kind of crazy. But again, take it one step at a time. Plug in what you know. Always mark up your drawings. So we have 3 circles, X, Y, and Z. Respectively, we have radii of 22 for circle X, 16 for circle Y, and 10 for circle Z. We're wanting to find EZ, this whole distance. Okay, so I'm going to plug in some numbers here. I know that this distance is 22, tells me the diameter. I know the diameter of the middle circle from X to Z, that is 16. And I know that the diameter of the small circle from F to G is 10. Okay. Now I am asked to find the distance from E to Z. Well, I know this much right here is 22. So I just need to find this part right here. Well, that's a radius of this small circle. If the whole thing is 10, this whole diameter is 10, what is this radius going to be? It's half, which is 5. Remember, radius is half the diameter. So now I put those two values together, and my distance is 27. Okay, on to another problem. Find circumference, diameter, and radius. Okay, so different problems we can do using the same formula. First, we're going to find circumference if radius is 13 inches. So we're going to start off with our circumference formula. You could choose the one with radius in it or choose the one with diameter in it. Since we are being given the radius, we're going to use the one with the R in it. And we're just going to simply plug that 13 in. 2 times 13 is 26. Remember, pi is a number, so we're just going to leave it there. We don't need to replace it. We aren't solving for it. This is actually the most accurate answer because we haven't estimated anything. So we're going to use an equal sign here. Now, if you were to replace this pi with an abbreviated or estimated value, which we say is 3.14, remember pi actually goes on forever. So this is very much estimated and rounded. If we were to do that and multiply it out, we would get 81.68. But because we rounded, that is an estimation. So we've seen this before in some other videos. This squiggly equal sign means about or estimated value. We've rounded it. I want you to use this. Number one, it's less steps. Number two, it's more accurate. So it's kind of a win-win. Just know if you were ever to take, say, a standardized test, SAT, something like that, where it took the answers to 2 or 3 or 4 decimal places, you would need to replace that pi with your pi button or 3.14, whatever the directions say, and carry it out to a decimal. So it's good to be able to know how to do it both ways. Okay, here's another one. We're going to find circumference again, but this time what are we given? We're given diameter. So we're going to use the other formula for circumference, the one that has the D in it. Plug this in. You really didn't need to even do any work. Okay, and we usually put the pi afterwards. It's not wrong to switch these, but it's just more proper to put the number first and then the symbol. So 6 pi. Again, that's our accurate actual value. Our estimated value for rounding pi is 18.85. So see if you can do one. If I tell you to find circumference with a radius of 22 centimeters, what do you need to do? Work it out. See if you stay ahead of me. Don't drop the pi. I see this happen a lot in students from the past. They do all the multiplication and they don't put pi in their answer. This is a number. It is part of your answer. It needs to stay there. Now, this is 44. Well, if it's 44 pi, 44 times 3.14, it obviously is going to be more than that. It's not going to be 22 because that's just the radius. It has to be more than that. All right. So even if you didn't have a calculator to figure this out, you could narrow it down. We could narrow it down even more because if pi is 3.14, 3 times 4 is 12, so it's got to be more than 69. It's going to be 120 something at least. So our answer is going to be D, 138.23. Using a calculator, this is what you would get. So again, it just kind of depends on what kind of situation you're in, worksheet, test, whatever. For my classroom purposes, you can leave pi in your answer, but if you're on some kind of standard testing, you might have to change it to a decimal. Okay, using figures to find circumference. Find the exact circumference. So again, we're not going to estimate anything here. How am I going to find the circumference? Okay, well, I start off writing down my formula. Circumference equals pi d or pi r or 2 pi r. So I need a radius or a diameter. Well, look, I have a right triangle here for which I have the hypotenuse. So I could probably work with that right triangle somehow to find my radius. Well, both of the legs of this right triangle start at the center and go to the edge. So what does that tell me? They are both radii, first of all, is what I know. And because they're both radii of the same circle, they are congruent to each other. So both legs are congruent. That means this is an isosceles right triangle. It is one of our special right triangles. If it's isosceles and it's right, then these angles have to be how many degrees? I hope you said 45. So this is a 45, 45, 90 degree triangle. And if you remember our pattern for the 45, 45, 90, the hypotenuse is square root 2 times the leg. So if this x is 3, what is my leg going to be? It's going to be 3. So my radius is 3. Now I can take that number, 3, and plug it in up here. 3 times 2 is 6. My answer is 6 pi. So you had to start putting things all together. Remember, in geometry, you cannot forget the things that we've learned in the past. Just because we have a test over it doesn't mean you just remove it from your memory. Concentric circles, what does that word mean? It means circles within circles. They have the same center, but different radii. So you start with the same center point and you just draw different size circles around the same center. And those are concentric circles. So it'd be like using a compass and just opening up your compass different distances each time. So these are concentric circles. Just know that term. You'll see it here and there. All right, that's it for today. Chapter 10, Section 1, the beginning of circles.